In this video, I'm going to discuss nuclear physics and the structure of the nucleus. So one of the things that we need to know as a piece of background information to understand the nucleus is Einstein's special theory of relativity. And really, this is, we're not going to go too much into detail about it, but essentially this is where the very famous equation E equals mc squared came from. And what this equation implicates is that mass and energy are interchangeable, or that mass is just another form of energy like heat or like kinetic energy. So the equation is that energy is equal to mass times the speed of light squared. We've already talked about sort of the electron arrangement, and we've calculated the energy of electrons. But now we're going to look at the nucleus specifically. So the nucleus contains the neutrons and the protons of an atom. We say that the proton number, or the atomic number, is the Z number. The neutron number is the N number. And if we add those two values together, we get the A number, which is the number of nucleons. In chemistry, we refer to the number of nucleons as the mass number, because protons and neutrons are roughly have an atomic mass of 1. But we'll look in a second a little bit more into detail about that. So if we're going to represent an atom of an element, we use nuclear notation. And the big X here represents the symbol for that element. And then to the left on the bottom, we put the Z number. The Z number never changes for an element. So if you're hydrogen, you're going to have a Z number of 1. You're going to have 1 proton. If you're lithium, you have a Z number of 3 and you have 3 protons. So your number of protons indicates what element you are. Now the A number can be variable because the number of neutrons can change in an atom. So an isotope is an atom of the same element but just having different number of neutrons, and therefore a different number of nucleons total. And so this value is written here in nuclear notation. And again, we can use these two values very simply to figure out, how many neutrons are present in that specific isotope for that element. So we've looked at the mass of subatomic particles. In chemistry, remember, you learned the mass is 1 AMU for a proton and a neutron and 0 for an electron. In physics, we actually, instead of calling it an atomic mass unit, we call it a unified mass unit. And it's a little bit more accurately here. You can see that actually a proton and neutron aren't exactly 1, but they're very, very close to 1 and very close to each other. And an electron is so relatively tiny that it does not affect the value of the overall mass of the atom. We've also looked at the mass of protons, neutrons, and electrons in terms of kilograms, as we've been doing our modern physics classwork assignments, but also when we were doing electricity and magnetism. So these are the values for the mass of a proton, neutron, and electron in kilograms. And I believe that these values are listed for you on your tables of information. Now, the other form of mass, or unit for mass, that we can talk about is using that equation of Einstein's special theory of relativity. So if we solve this equation for mass, you get energy over speed of light squared. And the energy unit that we use here is mega electron volts. So mega electron volts per speed of light squared. That gives you a unified mass unit of 1 being approximately equivalent to 931 mega electron volts per speed of light squared. So just another way of representing the mass of subatomic particles. One last thing I'm going to discuss in the video is the size of the nucleus. So when Rutherford discovered the size of the nucleus, we had to create a new unit for length because it was the smallest thing that we had ever been able to measure. So recall that the metric system goes in increments of 3. So -3 is milli, -6 is micro, -9 is nano. So the new size or unit of length that we came up for, which approximates the size of a nucleus, is a Fermi, which is times 10 to the negative 15th meters. So now that we understand the structure of the nucleus, in the next lecture I'm going to discuss the stability of the nucleus.